Hi, my name is Swati Sharma, and I am the NLP lead at Cedrus Digital. And today I'm going to talk about how Cedrus is leveraging NLP to extract insights from customer conversations. So just to run down the overview for our talk today, I'm going to go through a very basic and generic use case just to explain how critical this work is and how it can really make an impact in the day-to-day functioning of businesses and the brand loyalty as well. I'll go through a little bit about the methodology and break down how we are getting entities or topics out of utterances and the whole process of doing it, and our examination of what is the best approach of using this methodology. And then I'm going to share some very interesting results which are very compelling and support the work that we're going to do, which is to extract insights to really understand what the customer is talking about when they call up or communicate with a business. So if we were to understand customer service, we would need to understand both sides, the customer side as well as the business side. So resolving customer issues and answering queries is a huge area where businesses can really differentiate themselves. And it is a big endeavor for businesses to maintain quality customer service. It is very costly. And as a result, they want to have customers leaving satisfied with all their answers and issues resolved. However, from some research that I conducted, I found that about 75% of customers actually say that poor service is enough for them to encourage them to change vendors. So we can see that customer service is a critical part of the equation for the business. So the goal is to provide quality and targeted customer service. So So what are the issues exactly? So I know, speaking from personal experience, it can be very frustrating making a call to customer service. You know you're going to be there on the phone for a long amount of time, and it's going to be frustrating because you have to explain your issue, and sometimes things are not that easy to explain. We also found that younger customers, in particular those that have been labeled as millennials or Generation Z, they are fond of text-based interactions instead of actually picking up the phone and calling customer service. So we need to cater to this as well. So the reason why there's a little bit of change in how customers view customer service, it's because many times we encounter agents who have inadequate information. An agent is not going to know everything about everything. So it is difficult for them to assess and resolve every single issue. But for us as a customer, we want to get our issues resolved as quickly and as effectively as possible. And as I mentioned, sometimes the agents don't understand exactly what we are calling about, and we can get shuffled around, having to enter multiple prompts and having to speak to many agents and having to repeat our problem to them multiple times. So this is an added frustration and added effort to the customer. And every once in a while you will get, the off customer agent, and we don't really like, our interaction so much. So these are all reasons why this is such a critical issue for businesses to really target their communication with customers. And it's obvious that there is a huge demand for self-service. So how do we cater to this? How can we resolve these issues? So the goal is to convert to a more intelligent customer service. And Cedrus has done some really interesting work in this area using NLP. And this work not only benefits the customer, but it also benefits the business. Obviously, the business wants to have a financial benefit, as well as being able to really scale the call centers and reduce the costs of including new CSR agents. They can reduce the attrition of CSR agents, definitely reduce the wait time by perhaps utilizing bots instead of having to bounce the customer around to another agent. And also, probably one of the most best part of making an intelligent customer service is that we only need to train the technology only once, or at least periodically, depending on if there's any seasonal changes in what the customer may be calling about. But overall, this is a very scalable and consistent and very reliable intelligence that we can implement in enhancing the service. So as a result, the customers, they leave much happier and satisfied interacting with the business. So definitely a win-win situation. So how do we do this? So at Cedrus, we have a group of very talented data scientists who are working on this diligently in trying to understand how we can understand from historical data what these customers are actually calling in about. So we reduce them to utterances and then to entities. So essentially a conversation can be either a verbal conversation where we get for example, a voice recording, or it could be a conversation with a bot. And in that case, we will have data that is textual in format. So if we were to get audio data from the conversation, we would first have to convert it into a textual format. So once we have acquired the data in a textual format, we then, of course, have to go in and separate the customer voice versus the bot or the agent voice. And by voice, I meaning by their utterances, so what they're speaking. So an utterance is basically a statement that the customer makes. And in that utterance, we can harvest topics or entities, as they are also called. So if we're able to harvest and extract these entities and build it up over the entire conversation, we can really understand overall what customers are talking about and target the customer service approach in that manner. So to go deeper into the extraction process, of course, as you all know, data cleansing is a mandatory first step. It is a first step in every sort of machine learning or artificial intelligence problem that we as data scientists encounter. So when dealing with NLP problems, we have to use a multitude of approaches in cleansing that data. So some of them that we have used here at Cedrus is tokenizing, removing punctuation and special character removal. We want to make all the words uniform and remove capitalization and have everything as lower caps. So we're trying to get the data in a more standardized, uniform format, and that will also include stemming and lemmatization, where we break down these tokens into their root words. So at the end, we are left with a very clean data set that is pretty much standardized. And then we will go into our stop word removals. Of course, there is the basic NLTK a list, but we like to customize that stop word removal list and incorporate words that we feel will not add value in terms of understanding the overall topics or the topics for each utterance. So a lot of work is gone into really curating the stop word list. So these are several steps that we must first do before we really get into any sort of manipulation of the data. So once this is done, then we can move forward with the NLP entity recognition. So we are using entity recognition as topic modeling, and this is a completely unsupervised approach versus perhaps a rule-based text mining approach. You can use regular expressions. And this is also different from topic classification. Topic modeling is purely an unsupervised learning. We do not have any labels or anything of that sort, nor are we doing any sort of prediction at this point. Whereas topic classification, we already have data that is nicely labeled, and we can go ahead and predict what up and coming data would fit under. So we are doing unsupervised learning. So we're trying to create our own labels for a conversation, for an utterance. So conversation is a set of utterances. So we want to identify and organize all of the topics present. So just to give you an example of topic modeling, let's say you are a law firm and you just, have purchased a smaller law firm. So the first thing that law firm is going to do is try to organize all of the cases they have on file. And how do they do that? They first do it by topics, by major topics. And then once they get the major topics, they break it down into minor topics depending on the population of that minor topic. So essentially, entity recognition or topic modeling is the same process. We are trying to break down this entire corpus and organize it into a set of keywords. Now, we can use this further for clustering. We can use it for information retrieval, where we go and kickstart some sort of resolution action. We can also have it as a feature selection. Now, there are various topic modeling methodologies. I have listed just 3 of them here, but there are many more and many varieties of each one. So the first and probably the most simplistic approach is term frequency and inverse frequency, also known as TF-IDF. Now, this is a very, very simplistic approach. It is not very robust. It's just to give you an idea of underlying important themes. It doesn't really uncover latent topics, which is what we really want to do. We want to get into the meaning or the intent of the document and extract those topics in that manner. So probably better suited is the NMF, the non-negative matrix factorization. Now, this is a purely vector manipulation. It's very simple to PCA, where you're decomposing your corpus into smaller and smaller subsets until you can extract those keywords. Now, for our purpose at Cedrus, we found that a version of the latent Dirichlet allocation, the LDA algorithm, was the best approach. This is a probabilistic approach, and it is quite complex, but it suits this type of use case quite well. And that's because we're dealing with utterances which tend to be quite short. Whereas the NMF is probably better suited to larger documents. So that is why we went ahead with LDA. Now, LDA is one of the most popular topic modeling methodologies. It is very commonly used. And in fact, I invite you all to read Andrew Ng's seminal paper on LDA written in 2003, where he has beautifully explained how the LDA algorithm functions. Now, I'm just going to give you a very high level overview of how the LDA works, just so you get a feel for the intelligence that we're building in our capability here to really enhance the customer service. So essentially, when a customer communicates with either an agent or a bot, they're going to communicate for some amount of time, at least for more than one sentence, we assume. Obviously they're going to have casual intents and more business related intents. So we want to really get in and understand what those topics are. So LDA assumes that the document or the set of utterances is going to be comprised of multiple topics. Even utterances may have multiple topics. So each topic has corresponding words based on their probability distribution. So essentially, we're trying to find the cluster of words and how they relate to a topic, and then how those topics are distributed amongst the document or amongst the whole conversation. So we want to be able to capture the essence of each utterance and then take it a step forward and capture the essence of the entire conversation. So if we look at it this way, if we have a set of utterances or a set of documents, we are going to determine the importance of each useful word. So this is after we have done all the data cleansing steps that I enlisted earlier on. So we find the weight of each word, and we kind of go through this iterative process, and we understand what topic one is comprised of. And we understand that word one will have a certain weight, word two will have a certain weight. And the weight means the probability of that influence on that topic. So essentially, the entire document set of how many documents we have used. For example, if we have 3 of them here, so each topic is going to be multiplied by the weight, and the document is basically a weighted sum of each topic. Okay, so if we look a little deeper, we start assuming that we have K number of topics. And we can assign K arbitrarily, or as I'll show you a little bit later, there's a way to compute to some degree what the sweet spot for K is. But then we go through an iterative process. We go through the documents, and we start off by randomly assigning each word in the document to one of the K topics. So we just randomly close our eyes and pick. So, we don't really close our eyes. The algorithm will use a random approach of assigning words to the words to the topics. Okay, so then we loop through and we compute the probability of how much these topics are associated with the documents based on a given word. And we go through that and we adjust the weight of each word for each topic. And depending on how many iterations you have in place, it'll continue to loop around. And once you have reached the max number of iterations, we have the set number of weights for each word for a topic and for each topic in a document. So this is essentially what Gibbs sampling is. So LDA builds on Gibbs sampling. And for the LDA model, we have several hyperparameters that we can tune. Now, as you all know, it is essential to take that step of tuning the parameters in any sort of model that you create. That is how you really get the customized approach. And after a lot of experimentation and understanding the data that we have and the nature of the utterances, we have come up with some values for hyperparameters. Now, alpha and beta are two parameters that are the document topic density and the topic word density, respectively. So if you have a high alpha, it means that you have a lot of topics in your documents. If you have low alpha, you expect that your document or your conversation has very succinct topics, very few topics that are being discussed. So we are going to stick with a low alpha. And beta, which is the topic word density, which basically tells how verbose those topics are in the corpus. So a high beta is going to have a lot of words associated with that topic. And a low beta is going to be the situation where we have topics composed of few words, 1 word, 2 words, 3 words, depending on the type of data that you have. So for the utterances that we're going to look at, we found that a low alpha and a low beta were the best settings for us. Now, the number of topics, this is a little tricky to find out, and it really requires a lot of trial and error. So we implemented the train and test method where we get the coherence score, and there's a lot of documentation as to how to do this, what exactly a coherence score is, but it gives you an indication of how many topics you can extract with maintaining the essence of your information and not have too much overlap, because if you have overlap, then you can really have a diluted effect. So we want to have very distinct topics. And using these coherence scores, we're able to obtain that. So I'm going to show you some results, and our team has put together these results using just dummy data. So we are going to be showing you client agnostic results. And this data is actually the TripAdvisor data set, which you can find online and play around with as well. So this is what the data looks like. It's about 20K instances or 20K utterances. We can think of it in that way as well. Now, when we are dealing with customer service, we are getting about 40,000 utterances in a day. So it's huge data. We have plenty to work on and really extract good quality topics. And when you're dealing with LDA, it is important that you have a large enough data set in order to really extract quality topics. So we have the review, we have the ratings. So if we were to break down using LDA, this is the set of words that we would obtain as having the most impact in the document, as well as the weights. So if you look at the light colored bars, those are the actual counts, and the dark colored bars are the weights. So they don't always correspond, but we're able to cluster this into 4 different categories, which was great. So it gives us an idea of how many topics we wanted to look at. And if we were to break down each instance, each review, or each utterance in terms of the topics that we extracted using LDA, you can take a look at it here. So the green is one topic, blue is another, orange is another, and then we also have red. So you can obviously see that green is a huge player. A lot of discussion about the green topic. So if we were to break it down, we can get a look at how each topic has a weight in terms of for each document. So here you can see how we have the clean data, how we get the keywords and the weights. So we're basically breaking down the number of topics per document and taking a look. So if we were to look at the overall corpus and not at each document or each review, you can see overall that they align with 4 different categories of topics. So you can see here that topic number 3, which I will show you in the upcoming charts, has less of a visibility in this corpus, but nonetheless, it has a pretty good weight, so we're considering it as a topic. So again, if we look at the number of documents by the dominant topic, we can see that topic number 2 is a very popular point of discussion within the corpus. It's also the most highly weighted, which is good. So it validates our selection of topics when we have them widely represented in the documents, and also having the highest set of weights amongst all the topics that we extract. But if we were to look at 4 topics, these are what they would be. So if we were to cluster them, now this is a word cloud. If we were to cluster them and look at all the words associated with these topics, these are the words that we would find. So it's the topic and all of the associated words that show up in all of the documents or in all of the reviews. And if we were to show how these words are in relation to other words and other topics, this is what we would get. So the green, as I showed to you earlier, is a very high visibility topic, and the red one, of course, had the least visibility. So that's nice that we were able to get distinct topics using this methodology. Now, if we were to go in and refine these topics and really understand how many words we need to associate with a topic, we would go ahead and look at the coherence score. So you can see that we have a elbow at 8 topics. It really drops off there and then it picks up. But after that point, you have too many topics. So we went ahead and tried with 4 topics because that's what we were seeing so far. And it has a coherence score of about 0.85, which is pretty good. So if we were to look at how these 4 topics relate to each other, if we have bigram topics meaning we have 2 words associated with each topic. So you can see the topic 1 and 2 have considerable overlap. So we really want to avoid that. We want to have distinct topics so we can really target the issues. If we were to use this for customer service, we really want to target the issues in a impactful way and be effective as well. So we want to have distinct clusters. And this one on the right, we just showcase the bigrams for topic number 3. And you can see that highly recommend is a heavily weighted bigram associated with topic number 3. Now, if we were to look at topic 4, we see that staff friendly. So each topic has a different theme. It'll have a different set of bigrams associated with the topic. Now, what if we were to use trigrams? We really don't want to have too many topics and have a diluted setup. We saw that with 4, we were kind of getting a dilution there. But here we're seeing that we have a peak at 0.7 with 4 topics. So we're going to give it a go and show you what it looks like with 4 topics. But this time we're using trigrams. Okay, so we see that we get 4 distinct topics, which is beautiful. This is what we want to see. We want to see how we can target each area of concern in an appropriate way. And we're able to get 3 words associated with each topic. So it's more descriptive when we look at the topics and we build it utterance by utterance. So definitely we want to look at topics in a more complex way. So not only do we want to have a more descriptive topic, but we also want to do a layered approach, meaning that we build on it utterance by utterance. And we can see that we can really understand the whole conversation and assess what the customer is really discussing with the agent or the chatbot. So just to summarize really quickly, our team at Cedrus has been working on these NLP models, specifically using LDA to really extract valuable insights, utterance by utterance. And as you saw, we can build upon each utterance and get deeper into more latent topics. And by doing that, we're really able to target the customer service. We can prepare, meaning we can eventually predict, we can mitigate, we can even automate. We can have dashboards with metrics showing the weights of what topics are really relevant at that time, and really get the customer support agent or whoever is setting up the chatbot to really be prepared for what the insights are showing us. And as a result, the customer is left feeling very happy and satisfied with a quick and effective resolution. And this is definitely a bonus to the business. Not only are there huge financial savings in really streamlining the customer support service, but it also really enhances the logistics in providing the support. So definitely a win-win solution. And at Cedrus, we've been making a lot of amazing progress with this and helping businesses with their customer service support. And with that, I would like to thank you all. And please let me know if you have any questions or comments. I'd be happy to answer them.